Hi. This set of courses is designed for the mechanical engineering or aerospace engineering student who has completed their undergraduate studies and taken a thermodynamics course and wishes to learn more about the subject in depth. It's for engineers who work in fields like combustion, propulsion, high temperature gas dynamics, material processing, and so on. And for those who wish to learn about diagnostic techniques, advanced diagnostic techniques that might work for the systems that they study. My name is Professor John Daly. I started my career as a sports racing car mechanic and then went to the University of Michigan, where I got a bachelor's and master's degree. After that, I worked for Aerojet Liquid Rocket Company in Sacramento, California, and I worked on the space shuttle engines, the main engines and the attitude control system engines. After that, I went to Stanford University, where I received a PhD in mechanical engineering, and then started teaching in 1975 at the University of California at Berkeley. Following that, in 1988, I moved to the University of Colorado, where I have been ever since. I first studied statistical thermodynamics when I was an undergraduate at Michigan. I took the Stat Thermo course from Richard Sontag, Professor Richard Sontag, who was co-author with Gordon Van Wylen of a statistical thermo text. When I got to Stanford a few years later, I took physical gas dynamics from Charles Kruger. And this was the background that I took into Berkeley when I started teaching Stat Thermo. Shortly after arriving at Berkeley, my colleagues introduced me to the wonderful book by Professor Herb Callan of the University of Pennsylvania, in which he introduces the so-called postulatory approach to macroscopic thermodynamics. You might wonder what macro thermo has to do with micro or statistical thermodynamics, but the postulatory approach provides an extremely clear introduction to the concept of entropy and to the so-called fundamental relationship, which contains all thermodynamic properties. And so ever since then, I have incorporated that in both my stat thermo courses and my graduate thermodynamic courses. So after teaching this course for a number of years, I realized there was really no suitable book. And so I wrote one. It's called Statistical Thermodynamics, an Engineering Approach. It incorporates the concepts from Callan and from a number of other authors, but none of those concepts were ever present in one book in a suitable way that I thought flowed well in terms of teaching this subject. Coursera does not require a textbook, but you may find this book useful as you're following the course. And I will provide in the course material the reference you need in order to order one for your own use. Obviously, I'm a golfer, and they say, putt for dough, drive for show. So, and you might want to know what golf has to do with statistical thermo. But an important part of statistical thermo is collision theory. What happens at the molecular level, for example, in a gas when molecules are colliding with each other. And really, that isn't all that different from what I just did. So in this course, there'll be quite a lot of references to various software packages. Some of them are commercial, some of them are open source. The commercial packages tend to be easier to use, have a nicer interface, and so on. But they're not necessarily better than the open source codes. MATLAB, for example, is a code we use a lot at the University of Colorado, but the open source alternative is Octave, I guess. Octave is the name of it. And there are many other examples of that. You know, in this day and age, electronic stuff tends to come and go. And so really it's incumbent on you as the student, and of course me as the instructor, to be aware of that and to be as up-to-date as possible. But it may be possible that by the time you watch these videos, some particular code might not be available anymore, and you'll have to find an alternative. So that's basically the introduction to this course. And so I say we tee off. So let's see if I can do this. Thank you, and have a great time taking these courses.